Hello everyone, welcome to Computer Science and IT Gate Coaching. Don't forget to subscribe my channel and press the bell icon to get the instant notification of my free lecture. So this is about me. I am a computer science gate faculty having more than 5 plus of teaching experience, mentored more than 50,000 students, taught in different coaching institute all over India. Okay, it's like the Gate Academy, even qualified multiple times Gate, and even I have given the coaching in many government colleges as well as in many private colleges. Like in SRM Chennai, I have given coaching. CAT Bhubaneswar, I have given. BC Bhagalpur, Jorhat College of Engineering, Guwahati University, Dibrugarh University, Government College of Engineering and Technology, Jammu, Ramgarh Engineering College. Okay, these are the colleges where I have went and I have given the coaching. Now we will see left shift operator. Now we will see shift operator. Okay. And one thing, don't get confused between bitwise or and logical or. Okay, this is different between these two. Okay, this is logical or and this is bitwise or. Don't get confused between. Now, shift operator. The shift, the shift operators. This and this, that is left shift and right shift. Performs perform left and perform left and right shift. Perform left and right shift of their their left operand, their left operand, their left operand, whatever is in the left operand that will produce left operand by the number of by the number by the number of bit position by the number of bit position number of bit position given by the given by the given by the right given by the which must be which must be. So what I mean here is very important. The shift operator, that is left shift and right shift, perform left and right shift. So this is going to perform left shift, this is going to perform right shift of their left operand. Whatever will be in the left operand you will give, it is going to perform left shift or right shift by the number of bit position. Whatever number of bit position you are given, by the number of bit position given by the right operand. Okay. In right operand, whatever the number of bit position you have given, that is going to be, which must be positive. With example, it will be more clear. Take example x left shift 2. It is saying that x is a left operand. You are going to perform on x 2 left shift. 2 left shift. So like if you are having 1. So let me write first. Shift shifts the shifts the value of x shifts the value of x left by 2 position by 2 positions. By 2 position is going to shift the value of x left. It will shift the values of x by left by 2 position, which by 2 position, filling the vacated with 0, filling the vacated with 0, filling the vacated bit with 0. Okay, so like if you are having, so this is equivalent to this is equivalent to multiply by 4. This is equivalent to multiply or multiplication by 4. This is equivalent to multiplication by 4. Like if you are having x is having 1, so it is, you are doing x left shift 2 only, means this is bitwise 1. So it is you can write 1 as 0 0 1 bitwise and 0 0 1. Now you are performing this. It will be here two left shift, and left is going to be filled by vacated bit is filled by 0. So it is like 1 into 4. So it is bit, if you are doing two left shift, it is multiplied by 4. If you will do one left shift, it is multiplied by 2. It is multiplied by 2. Two left shift, it is multiplied by 4. Three left shift, it is multiplied by 8. Four left shift, it is multiplied by. So whenever you want to multiply any number x equal to x into 2. No need to do this, because multiplication is there. Bitwise operator work faster than that this arithmetic. Okay, because it is a bitwise bit, it will working internally only it is doing. You just do in place of this x equal to x by, it will work faster. So in a competitive programming, you use this instead of this. Okay, no, you want to do into 2, so it will be left shift 1, left shift. Let's take an example. With example, it will be more clear. Now take 1 2 4 6, sorry, 1 2 4 6 8 8 8 12 16 16 16. So I am taking 4 1 0 0. If I'll do one left shift, it will be 4 into 2 is going to 8. Now x, let's assume x is this. X left shift 1. It will be 1 then 0 0 1 bit vacated. So see, it is 8. Okay. This is the left. Now right shift. Left shift we have seen. Now right shift. Right shift is like divide by 2. Okay, right shift. But it is having some condition. Now right shift. Okay. Right shift. Right shifting. So here it is having different performance in case of, if it is a signed or if it is unsigned, it will perform differently. So right shifting and unsigned, right shifting and an unsigned quantities, right shifting and an unsigned quantity always always fills vacated bit, always fills vacated bits with 0. If you are doing right shift to unsigned quantities like 1 0, you are doing a right shift, so 1 will be here, this vacated will be 0. In case of unsigned quantities, unsigned, because 0 is used, so that's why in gate exam they will do right shift always on the unsigned quantities, because in case of signed quantities it is machine dependent. So right shift on signed quantities will depends on machine. On unsigned quantities it is always going to be filled with 0. On unsigned it is always going to be filled with 0. Okay, it is always going to be filled with 0. But in case of signed, it is machine dependent. Sometimes it will fill with 0, sometimes it will be 1. Okay, right shifting, right shifting a right shifting a signed right shifting a signed quantities, right shifting a signed quantity will fill with will fill with sign bit. Sometimes sign bit, that is sign bit on some machine. Okay, sign bit, sometimes it will fill with sign bit on some machine, and sometimes it will put 0 on some machine and with 0 bits on. Okay, so that's why in gate exam they will never ask you right shifting on the signed quantities, because it's machine dependent. It's going to be machine dependent. Okay, So generally, right shifting, right shifting, and and unsigned, right shifting and unsigned, right shifting and unsigned uh, quantity, right shifting and unsigned operand or unsigned quantity. So this is right shifting and unsigned quantities for unsigned quantity. So if you are doing right shifting one, it means divide by 2, means divide by 2. Right shifting by 2, it means divide by 4. Right shifting, it means divide by 8. Here means divide by 7. Okay. It is for unsigned quantities, not for signs, because for signed it is machine dependent.